Okay, so a little bit of science. I know, and we're in a science class. How boring. Anyway, latent heat. So latent heat is called hidden heat. Right? It's like the Latin for hidden heat. It basically means that if you want to melt ice, the melting of the ice doesn't actually change temperature. It's after all of the ice melts that the temperature. Nah. It's after all of the ice melts that the temperature starts to change. Okay, so melting 1 gram of ice requires 80 calories. That's latent heat. You won't see the temperature change. Right? Same with the freezing. It actually releases the heat, but you won't see a temperature change. Okay, and we do joules and calories, but don't worry about that too much. Right. So, I don't get to be with you. And even if I did get to be with you, I wouldn't make you do this. But you do this every day. You just don't notice it. So maybe next time you have a glass of ice water, like fill it up with lots of ice, and then stick a thermometer in there. I don't know if we even have those thermometers anymore, right? Because we used to have the type that you put under your tongue, and now we have the type that you like shoot at your forehead. And no. So if you have the old-fashioned type, just stick it on the in your water next time you go to drink your ice water, and you'll see how the temperature doesn't change. But because we probably don't have those thermometers anymore, and I didn't get you prepared to do that, and watching ice melt is, well, as exciting as watching grass grow, right? And this is from a water person. So I found a video for us.
Specific latent heat is the amount of heat energy required to change the state of a unit mass of a substance without change in temperature. The word latent means dormant or concealed. Let's perform an activity to find out why the heat energy required to bring about a change of state is called latent heat. Take some ice cubes in a beaker. Suspend a thermometer into the ice cubes and note its temperature. The temperature is 0 degrees centigrade. Heat the ice cubes. Record the temperature after every minute. Keep stirring the ice-water mixture constantly so that the temperature is uniform throughout. We observe that the thermometer reading remains constant at 0 degrees centigrade, though heat is being constantly supplied. The temperature remains constant till the ice completely melts to water at 0 degrees centigrade. Continue heating water which is at 0 degrees centigrade. We observe that the temperature is increasing. Record the rise in temperature till the water starts boiling. Continue heating. The boiling water gets converted to steam. Observe that the thermometer reading remains constant at 100 degrees centigrade, which is the boiling point of water. That is, there is no change in temperature. This shows that the temperature remains constant whenever there is a change of state. What happens to the energy supplied? The energy supplied is used to break the intermolecular force of attraction existing between the molecules, and therefore the thermometer does not register a rise in temperature whenever there is a change of state. Since the energy supplied is not recorded in the thermometer, the heat supplied is called latent heat. Graph shown here represents the changes taking place when ice at 0 degrees centigrade is heated.
Super exciting, right? It'd be even more exciting if you had to draw that graph. Just saying. Okay, so you've already seen this picture over here, right? And we've already talked about melting, freezing, evaporization, condensation, sublimation, and deposition. But just on a more in-depth thing, right? Evaporization, converting liquid to gas, right? And it has a latent heat. Now this latent heat is called latent heat of vaporization because you're making it into a vapor, right? So latent heat of vaporization. So the energy is absorbed by the water. And this is interesting. energy is absorbed by the water. So the energy around, in order for it to evaporate, is absorbed. That means that evaporation is a cooling process, right? So when you get out of the shower and you're cold, that's because the water droplets are taking the energy from you and using your heat to evaporate. So that's why they leave you to be cold and shivering. It's also why, before we get into condensation, it's also why they claim dry heat, right? Because when you sweat, the same process is happening. Those water droplets are taking your heat in order to evaporate, right? So in the middle of the desert, when you sweat, as soon as you sweat, the atmosphere is like, I want that air. So it takes your energy to evaporate that air, or that water, into the air, right? So you cool down. But when you're in Disney, you sweat, and the air's like, no, you can keep it. So it doesn't take your energy to evaporate it, it just leaves it there so you don't get cooler. Right. Condensation. Again, you already know, condensation, gas to liquid. So this also has a latent heat of condensation, right? And this is a warming process. Sublimation, right? Dry ice, talked about that. Deposition, changing vapor to a solid. Frost, right? Frost is when the water gets so cold, well, the vapor gets so cold that it just lands as ice on whatever it is. It looks gorgeous from here in Florida.